Not my best soldering work, but it should do. What I've got here is hopefully a revived real-time clock. This is the real-time clock that was on my Amiga 1000 DKB Insider II board. Goes onto the board right there. It is a Dallas 1216 chip. Inside of there. And then this has 2 batteries potted within epoxy. So there's a video, I'll put it in the description, that I followed, where basically you can kind of see the round batteries, and each one has a lead. This lead goes between pins 8 and 9, and that one is by the last pin. So you take a Dremel, and you want to cut the leads from the batteries. So internally there's obviously a positive and a negative lead. I don't know if these batteries are potted with positive up or positive down, but by cutting this lead, you're making it so the batteries are no longer hooked up to the actual chip, which is inside there. It's a smaller chip than this size of the socket. Because some computers that use this same real clock chip will put another chip on top that has pins with this spacing, as opposed to the Dallas actual clock chip that's in there that's much smaller. So it's in a little tiny circuit board, and under that circuit board are 2 batteries, and then it's all glued up. So once these batteries die after 10, 20, 30 years, it stops keeping time, and they haven't made these for years. I actually was astonished to see them on eBay. There's quite a few of them there. I don't know if any of them have been produced within an amount of time that'll make them actually still function, but they're all going to die eventually because these batteries will die and they're not replaceable. So the video that I'll attach, a guy figured out how, just by looking at the diagram for the actual chip that's in the sandwich here, the Dallas 1216 chip, how to revive it with an external battery. So basically what I did is use parts on hand. I had a 2032 battery holder. I think I got it on Amazon, a package of different sized perforated through-hole boards. And then I just took a Dremel and cut it to the size I wanted, and put this battery holder on sideways because it didn't really fit up and down right, so I got it on sideways. And then I soldered leads, extension leads, whatever you want to call them, pins, that go into the socket below to hold it in place. And I soldered wires, as you'll see in the video. Pin 4 goes to positive terminal for the battery. Pin 8 on the internal chip goes to the negative of the battery. And that's all he did, and his worked fine. But per the comments in his video and the documentation, it says if you're only using one battery, you should ground pin 14. So what I did, pin 14 is here inside on the chip, and none of the, well, I didn't check all of them, but the pins here do not match up with the pins on that internal Dallas chip. So pin 14 there, to ground it, I found that this pin is tied to ground in this application. So if you look at the Insider motherboard, that pin right there, that is a ground trace. It goes around the board. It also connects to pin 53 of the 68,000 CPU, which I looked up the pin out. It says pin 53 is ground. Sure enough, pin 53 is also connected to this ground wire, which is connected to that part of the lower part of the chip that gets soldered in. So when this is soldered in the orientation that it was originally in, I've got ground going to pin 14 of the Dallas chip, and I've got positive battery and negative battery going to the Dallas chip, so that should make this real-time clock work and keep time. And all I should need to do now is put a battery in it, solder it back on the board, put it back in the Amiga 1000, which this wire came off when I was trying to do it without breaking this wire, but the connection to the wire to the board right down here, this lower hole, was about to fail anyway. But yeah, hopefully that'll make the real clock actually remember the time. Now, I don't know if anyone has changed the code to make it Y2K compatible. I'm guessing not on the Amiga. At least I don't think I saw anything when I was looking online. Whereas I did see, I think it was for Atari possibly, or DOS. Somebody had figured out how to modify the code, not on this chip, but on the PC side, so that it would be Y2K compliant, because it only stores 2 digits for the year on this. So I don't know what year I'm going to set it to, or if anyone's updated the code. Also, the code is on the disk that came with this. I can't remember the name of the command you use. I think it's something like RT clock for real-time clock. And then you give it the date and time that you want to set it. So I have to look that up, and I have to figure out, because I'm still messing with hardware, I haven't done much on the software side, I have to figure out how to get that onto a Workbench disk so that it will see it, because if you just boot off a generic Workbench disk, maybe it'll see the real... No, I don't think it'll see the real-time clock, because it doesn't use the standard clock settings, if there are any, when the machine boots up and says no real-time clock found. I think I have to add the software from the DKB Insider disk to Workbench for it to actually interact with the real-time clock, but I'm not positive on that. The first step today was to, basically following the instructions on the video I'll link, make my own version of this. So it's now got a replaceable 2032 battery. So the next step is to solder it in the board, resolder the connecting wire that came unsoldered, and then see if I can figure out how to get the software to work. All right, there is the battery on the real-time clock in place. I also added a DuPont connector and a pin to where this wire was normally soldered, because it came off when I was working on the board. And I decided that even though that's technically modifying the board, if I have to take it off again, I don't want to deal with this wire. It's attached to a plastic clip that goes under, and I think it's one of these pins here that it's attached to, so it's a pain in the neck. So now it's easily removable from there. I'm not using the GoTech right now. I am using the floppy drive, and I set the clock for 23:15 3 hours ago. Now I did set it for 1987 because there's only 2 years on this clock, and I don't think it handles Y2K. So 1987 has the same weekdays as 2025. So there is the difference. You can see the RT clock. So I'm loading that instead of the normal Amiga startup sequence clock routine. And you can see that it did load the program. So, okay, this is, I didn't count on this. I didn't want to make this video that long. And I still don't have a mouse. Come on, focus here. I thought it would show the time. So I'm using the cursor keys here. There we go. I set it for Tuesday, the 25th of February, 1986, 23:15. It is now 3 hours later, and it's now the 26th at 2:15. So, the machine was powered off for 3 hours, and it maintained the time. So it looks like that was a successful hardware modification. It took, as I said, the normal, was it set clock command that's in the startup sequence on the workbench disk. There's a line that says set clock load. I changed it to RTC. Sorry, I keep saying that. RT clock. Load RT clock, and it loaded on boot, as you saw, and you issue RT clock, and it shows you the time. So it now has a functional real-time clock.